Welcome to a slow, beginner-friendly lesson on combining expressions, made for absolute beginners. Final A.2 lesson, how pieces combine. Light precedence only. Parentheses for clarity. Then we stop. Functions are A.3. Until now, each expression we wrote used a single operator, 1 plus, or 1 equals. Real programs rarely stay that simple. A shop discount might check whether the total is large enough and whether the customer is a member. That is arithmetic to compute the total, comparison to test a threshold, and a logic word to join the two checks. Combining expressions simply means letting several operators share one line to express a complete rule. Several operators, one rule. It helps to name the three families before mixing them. Arithmetic computes new values, plus, minus, star, slash, and the rest. Comparison asks a question and returns a bool, equals, less than, greater than. Logic joins those bools together using three small words, and, or, not. Today we let all three families share a single line. The only new members are the three logic words, so let us meet them first, one at a time. Name the ingredients. We have met arithmetic, and we have met comparison. Today they meet each other, joined by three small logic words, and, or, not. Combining them is how real rules are written, from password checks to shop discounts. One line can quietly carry a surprising amount of meaning once you know how it fits together. Three families meet. The word enjoins two bools and returns true only when both are true. True and true is true. True and false is false, because one side failed. False and false is false. In practice, age greater than or equal to 18 and age less than or equal to 65 is true only when age sits inside that whole range. Think of it as a strict bouncer, every condition must pass, or the whole thing is false. Both must be true. The word or is far more relaxed. It returns true when at least one side is true. True or false is true. Only false or false is false. A practical use is checking membership in a set of options. Day equals Saturday or day equals Sunday is true on either weekend day, so the variable weekend becomes true on a Sunday. Think of or as a generous host, any single condition passing is enough. One is enough. The word not flips a bool. Not true is false. Not false is true. It only takes one value, so it is a unary operator rather than a binary one. A common use is turning a negative flag into a positive thought. If raining is false, then not raining is true, meaning it is dry outside. Not lets you express a rule in the most natural direction, and then flip it when you need the opposite. Flip the answer. Nothing here is truly new. Every piece is a brick you already hold. The only new skill is stacking them confidently and knowing which brick Python picks up first. Once that order feels natural, a long expression stops looking like a puzzle and starts looking like a sentence you can read aloud. Familiar bricks, stacked. Now let us combine the logic words with real checks. Age greater than or equal to 18 and member is true when the person is both an adult and a member. Age less than 18 or not member is true when either they are underage or not a member. For age 30 and member true, the first is true and the second is false. Notice the words and or can chain several checks into one readable rule. We will see the order they evaluate in just a moment. Join the real checks. When all three families share a line, Python evaluates them in a fixed order. Arithmetic binds tightest, so plus and star happen first. Comparison comes next, turning values into bools. Logic is loosest of all, and within logic, not is tightest, then and, then or. You do not need to memorize every rung. You need to feel that arithmetic beats comparison, and comparison beats logic. And you need to remember that parentheses override the entire ladder whenever you want to be sure. Which binds tightest? Here is precedence in action. 1 plus 1 equals 3 and 5 greater than 2. Python does not read this left to right at random. It computes arithmetic first, 1 plus 1 is 2. Then comparison, 2 equals 3 is false. Then logic, false and true is false. So the whole line is false, even though 5 greater than 2 alone is true. Knowing the order lets you predict this without running the code. That predictability is the whole point of precedence. Order predicts the result. This lesson finishes the foundation. After today you have variables, types, arithmetic, comparison, and now the glue that joins them. Everything that follows, conditions, loops, functions, rests on exactly these pieces. Take a moment to appreciate how much solid ground you have already covered. The foundation is done. Whenever an expression mixes and or, the meaning can get fuzzy without parentheses. 2 plus 3 equals 5 and 10 greater than 4 or 1 equals 2 is technically defined, but hard to read. Wrap the parts that belong together. Parentheses around the first two checks, then or, Then the last check in its own group tells every reader exactly how you group the rule. The result is identical, but the intent is now obvious. Parentheses are a gift to your future self. Say exactly what you mean. A question beginners often ask is, do I really need these parentheses if Python already knows the order? Technically, often no. But code is read far more often than it is written, and the reader may be you, tired, months later. Clear beats short every single time. If you have to puzzle out what an expression means, add parentheses and make the grouping explicit. The Python philosophy says readability counts. Treat that as a standing instruction, not a suggestion. Clear beats short. When an expression grows beyond 2 or 3 checks, the kindest thing you can do is break it into named variables. Instead of one dense line, compute qualifies as total at least 50, compute in good standing as member and not blocked, then combine those two named bools. The logic is identical, but now each part has a name that explains its meaning. A reader can follow the rule like a sentence. Named variables turn a puzzle back into plain English. Names carry the meaning. As expressions grow, 2 tools keep them honest: parentheses and well-named variables. Parentheses state your intent unambiguously. Named variables explain what each sub-result means. Reach for them the moment an expression stops reading like plain English. Clarity is always the goal, never clever density. Here is the same idea with arithmetic mixed in. Score is 88, extra is 5, and final is score plus extra, 93. Then high becomes final greater than or equal to 90, true. Honors becomes high and not failed. Notice how each variable name describes its meaning: final, high, honors. The last line reads almost like a sentence. The computation is no more complex than before, but it is now a pleasure to read and a pain to misread. A pleasure to read. The reliable habit is to build up in steps. First, compute the values you need with arithmetic. Then turn each individual check into a named bool. Finally, combine those named bools with the logic words. This way, when something is wrong, you can inspect each named piece on its own and find the faulty link. A giant one-liner hides the problem. A chain of small named steps reveals it. Prefer small and clear over big and clever, always. Small steps, easy debugging. One small gotcha worth knowing. You can chain comparisons against a single value, like 18 less than or equal to age less than or equal to 65. But you cannot write age greater than 12 and less than 20, the way you might in English. Python raises a syntax error because the second half has nothing to compare. You must repeat the variable, age greater than 12 and age less than 20. Or, better, use the chained form, 12 less than age less than 20. Both are clear, just remember to name the value on both sides of the AND. Name both sides of AND. A real program mixes everything at once. A little arithmetic produces a value, a comparison turns it into a bool, and a logic word joins several bools into one final decision. Seeing that whole chain, end to end, is the real reward of this lesson. You are no longer learning pieces. You are reading complete thoughts in code. A quick challenge to lock it in. Predict each result before reading on. X greater than 2 and X less than 10 is true, since 4 sits inside that range. X plus 1 equals 5 or X equals 99 is true, because 5 equals 5 on the left. Not if X greater than 100 is true, because the inside is false and not flips it. If those felt automatic, you own the combination. Predict before you peek. Here is the pattern in a realistic shape. Total is 60, member is true, coupon is false. Free shipping is total at least 50 and member, which is true. A discount applies when the total is over 40 or a coupon is present, which is also true. Notice how each rule is one readable line of combined checks, and each result is a named bool the rest of the program can trust. This is exactly how real programs encode real business rules, one clear expression at a time. One rule, one clear line. Because this lesson closes phase 8.2, let us look back at the whole foundation you now hold. You can declare variables and name them well. You know the core types: integer, string, bool, float, and none. You can mix types carefully using converters. You mastered arithmetic, including the 2 divisions and modulo. You learned comparison and the golden rule of 2 equals. And now you combine all of it with logic words. That is a complete foundation for everything that comes next. Look at what you built. Let us hold the whole lesson in one breath. The 3 logic words, and, or, not, join bools into richer rules. Precedence runs arithmetic first, then comparison, then logic, with parentheses overriding everything. And when an expression grows complex, you break it into named variables so each part explains itself. The goal is never the shortest line. The goal is the clearest line. If those sentences feel solid, you can read any expression Python offers. 4 true sentences. The takeaway, compressed to one line. Real expressions mix arithmetic, comparison, and logic, and Python evaluates them in a fixed order: arithmetic tightest, then comparison, then logic. When the order could be misread, add parentheses. When the line grows long, break it into named variables. Phase of point 2 is complete. You now hold the full foundation of expressions. In the next phase, we put these expressions to work inside conditions, loops, and functions. Take a breath. You just finished the foundation. Phase complete. Thanks for watching. You finished A.2. Next up, functions in section A.3.